Hello students, welcome back to the video lecture series of numerical methods in chemical engineering. We have started chapter number 5. The name of the chapter is finite differences and interpolation. Till now what we have completed? First of all, we seen about the finite differences. Then we studied about the Newton's forward difference formula and Newton's backward difference formula. Newton's forward and Newton's backward difference formula are also known as interpolation with equal intervals. Why equal intervals? Because the difference in the values of x is same. Okay, the difference in the values of x is same. That is known as interpolation with equal intervals. In today's lecture, we are going to study about the interpolation with unequal intervals. And we have already studied in the classification that there are two methods that are included in that. Which are the two methods? The first one is Newton's divided difference and the second one is Lagrange's interpolation. In today's lecture, we are going to study about Newton's divided difference method. So let us start. Okay, it is an interpolation technique that is used when the interval difference is not same for all sequence of values. The values of x will be given, but the difference in the values of x will not be same. So this is known as interpolation with unequal intervals. Now why it is given the Newton divided difference interpolation name, that we will study in the further upcoming slide. Okay. See here also in this interpolation also the values of x and y will be given. The values of x will be given. For example, the arguments. The values of x are also known as the arguments, right? So for different values of x like x0, x1, x2, x3, we are having the function value. Y is equal to f of x is the given function and we are having the different function values like f of x0, f of x1, f of x2 and so on up to f of xn. These are the n plus 1 values of the function y is equal to f of x. On the basis of this, we can find the different divided differences and that can be easily understood with the help of the table, and that table is known as divided difference table. So let us draw the divided difference table and then we will derive Newton's divided difference interpolation formula on the basis of that table. Okay. See, the first column will be x, the second will be f of x, then first divided difference, then second divided difference and third divided difference. Here we are taking 4 values of x, x0, x1, x2, x3 and the respective function values will be f of x0, f of x1, f of x2 and f of x3. Okay. See, first dd, second dd, third dd, what is the meaning of that? Okay, first divided difference is denoted by f of x0, x1. Okay, then it is also denoted as f of x1, x2 if the variable are changing, right? If I am writing for x2, x3, then it will be f of x2, x3. How I can find this value? See, as the name suggests, divided difference means we have to take the difference of y as well as x. See, these are the values of y, so we have to take this difference. In first divided difference, the value can be written as f of x1 minus f of x0 divided by x1 minus x0. So we have to also take the differences of x. So this is the first divided difference. F of x0, x1, how it can be written? F of x1 minus f of x0 divided by x1 minus x0. Similarly, I can write f of x2 minus f of x1 divided by x2 minus x1, and this can be written as f of x3 minus f of x2 upon x3 minus x2. In the first divided difference, we are directly taking the values of x, like x1 minus x0, x2 minus x1 and x3 minus x2. But in second divided difference, the things will change, okay. The second divided difference is denoted as f of x0, x1, x2, f of x0, x1, x2, and I can also write f of x1, x2, x3. Okay, how I can find the value of this? See, this can be found by f of x1, x2 minus f of x0, x1. See here I have to take the difference of x2 and x0, okay. So it can be written as x2 minus x0. See, remember, if it is second divided difference, then you have to leave x1 between them. So there should be a gap of one value in the sense, if I am writing from x2, then x1 is not to be written, we have to directly take x0, so x2 minus x0. Similarly, I can take the difference like this, f of x2, x3 minus f of x1, x2 divided by x3 minus, leave this x1, so I have to take here x3 minus x1, okay. So there should be a gap of one value, right? In the second divided difference, there should be a gap of one value in the difference of x, okay. And the third divided difference can be written as f of x0, x1, x2, x3. And how I can find this? I have to take the difference of these two, difference of the two second divided differences. Now, which are the two second divided differences? F of x1, x2, x3 minus f of x0, x1, x2 divided by, we have to take a gap of two values, so it can be written as x3 minus x0. So I have to write here x3 minus x0. So in this way you can find all the divided differences with the help of this table, okay. Remember, in first divided difference, it can be written as f of x1 minus f of x0 divided by x1 minus x0. There is no gap in the values of x. There is no gap in the difference of the values of x. In second divided difference, we have to take these two values x2 and x0, and for second divided difference x3 and x1. Similarly, for third divided difference, we have to leave two values, so we can take the difference like this, x3 minus x0. I hope it is clear to everyone, because on the basis of this we have to derive the Newton's divided difference interpolation formula. See how it can be written. Let us write the divided difference interpolation formula. It can be written as the first value, f of x0 plus x minus x0 into first divided difference, f of x0 x1 plus x minus x0, x minus x1. You have to take the difference of two values of x into second divided difference, f of x0, x1, x2 plus three values of x you have to take, three values of x you have to subtract from x, so x minus x0, x minus x1, x minus x2 in multiplied by f of x0, x1, x2, x3. This is our third divided difference, and so on. So this is Newton's divided difference interpolation formula that we are going to use to solve the numericals of this method. Okay, let us solve a numerical on the basis of this. We have to find the solution using Newton's divided difference interpolation formula for x is equal to 301. Okay, for x is equal to 301, we have to find the value of y. The values of x and y are already given. See, remember here the values of y. In the values of y, there are 4 decimal places. Okay, after decimal point, there are 4 digits. So we have to fix the calculator in 4 fixed mode, right? We have to select 4 decimal places in the calc, which is our first step. See, first step is to find the divided difference table. So I have already drawn here the divided difference table. Okay, the values of x and y are already given. Okay, this is the value of x, x0, x1, x2, x3. Let me write this. x0, x1, x2, x3. And this is my f of x0, f of x1, f of x2 and f of x3. See, this is my first divided difference, f of x0 comma x1. How I can find this? It can be found by taking the difference of y divided the difference of x. So this can be found by 2.4829 minus 2.4771 divided by 304 minus 300. So my answer will be 0.0015. How I can find this? See, take the difference of these values, 2.4843 minus 2.4829 divided by 305 minus 304 is 1. So this is my answer. Okay, similarly you can also find the difference like this, 2.4871 minus 2.4873 divided by 307 minus 305. Okay. Now this is my second order difference, f of x0, x1, x2. How it can be found? See, it can be found by taking the difference of this value minus this value. So it can be found by 0.0014 minus 0.0015 divided by, we have to leave a value of x, we have to take the difference of 305 and 300, right? So 305 minus 300, if you will find that and fixing the decimal places to 4, your answer will be 0. Similarly, this will be also 0. Which values we have to take here? This value minus this value, that is 0, divided by 307 minus 304. We have to leave one value of x in the difference. Okay. So there is no need to find the third order difference. Okay, by placing all of these values in the Newton's divided difference formula. Okay, let me write the Newton's divided difference formula. Y of 301 f of x0 plus x minus x0 into divided difference f of x0 x1 plus x minus x0 into x minus x1 into f of x0, x1, x2. Now what is our f of x0? See, this is our f of x0. So I can write here 2.4771 plus x. What is our x? See, x is given 301. So 301 minus x0. What is our x0? 300 minus 300 into first divided difference, that is 0.0015. Okay, 0.0015. And after adding this, after solving this, my answer will be 2.4786. So my value of y for x is equal to 301 will be 2.4786. So in this way you can solve the numericals of Newton's divided difference formula. Okay, you have to make sure that you are making the table correctly. Okay, if the table will be correct, then you can easily solve the numericals. Okay. Okay, let us solve one more numerical on the basis of this. Here, f of x is equal to 1 upon x is given and we have to only find the divided difference. There is no need to find the value of y or anything like that. We have to just find the value of f of a comma b and f of a comma b comma c. Okay, so it can be clearly understood with the help of the table. Here I am writing x and f of x. What is our f of x? 1 upon x. See, here the three values of x are taken as a, b and c. Okay, because our x0, x1, x2 are a, b and c. So what will be my f of x? See, f of x will be 1 upon a, 1 upon b and 1 upon c. Okay, here it will come first divided difference, then second divided difference. How I can write the first divided difference? It can be written as f of a comma b and this is f of b comma c, and the second divided difference can be written as f of a comma b comma c. how I can find the value of f of a comma b and f of a comma b comma c. So let us find that value f of a comma b. It can be found by taking the difference, by taking the divided difference. So 1 upon b minus 1 upon a. Okay, 1 upon b minus 1 upon a divided by b minus a. So it can be written as a minus b upon ab into b minus a. If you will simplify this, it can be written as minus 1 upon ab. So what is our f of a comma b? F of a comma b is minus 1 upon ab. Similarly, I can write here minus 1 upon bc. Now how I can find f of a comma b comma c? See, f of a comma b comma c can be found by taking the difference. So minus 1 upon bc plus 1 upon ab divided by c minus a. We have to take a gap of 1. So c minus a it can be written. Okay, let us simplify that. Minus ab plus bc upon ab square c into c minus a. Here I can take b common. See, b will be common. C minus a upon a into b square c into c minus a. C minus a gets cancelled. So what is my answer? 1 upon abc. So our two answers are minus 1 upon ab and 1 upon abc. See, in this way you can solve more numerical on the basis of this from the question bank. Okay. In the next lecture we will study one more method, that is Lagrange's interpolation. Till then, have a good day. Bye bye.